Today's learning intention is finding the area under a curve, part 2. Right, it's going to get a little bit more trickier. As again, our National 5 essential skills haven't changed. Hopefully you're getting better at simplifying surds and indices, working with fractions and integers, and you need to make sure that you know how to integrate, how to evaluate limits. So what happens now? I've got area under a curve. Find the area between the function and the x-axis between x is -3, as shown, and x is 3. So now part of the curve is below the x-axis and part of the curve's above the x-axis. Again, it's just the easy straight line, f of x equals x. So area equals integral from -3 to 3 of x dx. So integrating, that's we got half x squared from -3 to 3. Now when I sub in my limits and I evaluate, I end up with 9 over 2 minus 9 over 2 equals 0. So calculus is now telling me that the area between the curve equals 0. Now, we can look at the picture and we can see straight off that the total area is obviously not 0. I can see two triangles, so what's gone wrong with the calculus? There's a triangle here and a triangle there. So it looks like we're going to have to evaluate two areas independently and add them together, because we can see now from the calculus that the areas are identical, but one's below the x-axis, one above the x-axis, and they're cancelling each other out. Let's have a look. So we need to do separate integrations for above and below the x-axis, so we're treating it like two separate areas and add them together. Area 1. Area 1 equals the integral from 0 to 3 of x dx. So integrating it, same as before, sub in our values for upper minus lower, we now get 9 over 2 minus 0 equals 9 over 2. So area 1 is 9 over 2 square units. What about area 2 then? So area 2 equals the integral from -3 to 0 of x dx. Again, it's just the same as a half x squared, from x is -3 to 0. We sub in the limits, and the answer is now negative. It's minus 9 over 2. Now the negative sign indicates for you, if you haven't got a picture of your function, that the area is below the x-axis. But the area is just equal to 9 over 2. We ignore the negative sign. So our total area is, now we're going to add two areas together. It's 9 over 2 plus 9 over 2, which is 9 square units. Here's an example for you to try. I've got a graph here, y equals x squared minus 4x, and it says calculate the shaded area. It's a simple area, but it's below the x-axis. So we integrate as normal. So we integrate x is 1 to x is 4 of x squared minus 4x with respect to x. So we integrate, we get a third x cubed minus 4x squared over 2 from x is 1 to x is 4. Sublimits and evaluate, upper limit minus lower limit. Put in the numbers, and here we get the answer equals -9. Now the minute you see -9, you're saying to yourself the negative. That's just telling you that the area lies below the x-axis, so the shaded area equals 9 square units. Example 2, a little bit more complicated. You can see the function, we've got a cubic function here, y equals x cubed minus 3x squared plus 2x, and it says calculate the total shaded area when p equals 0.10 and q equals 20. So down the bottom I've got little hints for you to find the limits, roots and factorise. Now here we've been told the limits. Calculate area 1, calculate area 2, and add those two areas together. We're going to ignore any negatives and remember to put your square units at the end. For example 2, we've now got a cubic function, y equals x cubed minus 3x squared plus 2x, and it says calculate the total shaded area, and it's telling you that the point P is the 0.10 and Q is 20, so they're the roots of the cubic function we have here. Okay, now there's hints and tips at the bottom. It says find the limits. That equals the roots. Now we normally have to factorise, but I've told you the answer in this case, so the roots are going to be x is 0, x is 1 and x is 2. Calculate area 1, we're going to integrate, calculate area 2 by integration and add the two areas together. We ignore any negatives because that's just telling us the area lies below the x-axis, and remember to write square units at the end. So area 1, that's the first area we come to. We're going to integrate the function from x is 0 to x is 1, that's the limits, of x cubed minus 3x squared plus 2x dx. So we integrate, we evaluate the limits, and we calculate the area to be a quarter square units. Now you take your time to go through that and make sure I've not made any mistakes on that. Calculate area 2. We're integrating now from 1 to 2, so the limits have changed from x is 1 to x is 2, but the function stays the same. It's still x cubed minus 3x squared plus 2x with respect to x. So we've done the hard work already, we've already integrated, so we've got area 2. We're going to sub in the limits, they've changed from 2 to 1. Evaluate, and we get the answer negative a quarter. Now that function looks symmetrical, so I'm not surprised I've got the answer to be a quarter. The negative is just telling me that the area lies below the x-axis. So the area 2 equals a quarter square units. To find the total area, we just add the area 1 to area 2. So we've got a quarter plus a quarter, which equals a half of a square unit. Right, time for you to try this past paper example on your own. Looks a bit complicated. The diagram shows a sketch of the graph y equals x plus 2 times x minus 1 times x minus 2. Now beautifully, they've factorised it for you already. That means it should be dead easy to work out the roots. And part E is just saying write down the coordinates P and Q. It's been factorised, dead easy. Okay. It then says find the total shaded area, and I've got a hint for you here. You have to prepare to integrate. That means you multiply out the brackets first. It's a cubic, it's a positive cubic, you know that from your functions in graph section of the course. It's 7 marks, so this is a lot of work you've got to do now. Okay, so I want you to pause me, try it on your own, figure out why you're getting 7 marks for part B, come back and unpause when you're ready to reveal the answer. Right, best of luck, here goes, here's the answer. F of x equals x cubed minus x squared minus 4x plus 4. When you integrate that, you add together, you get your total area equals 5 over 2 square units. Any problems, talk to your teacher as soon as you can. Self-assess your progress. How did you get on with this lesson? Did you manage to do the try it on your own question? If you did, well done for getting 9 out of 9 for a past paper question. For extra practice, try page 177, exercise 9N from your maths textbook. So what have we learned today? Well, you've learned how to find the area under a curve. The integral has a negative value when the area lies below the x-axis. If we're dealing with two separate areas, we need to be treated as two separate integrals when one area lies below the x-axis. Add together the areas to calculate the total area.